Welcome to video 35. This video is all about file handling with CSV file data, tables and two-dimensional arrays. So the purpose of this video is for you to understand how we can work with tabular data in CSV format using two-dimensional arrays. Two-dimensional arrays you can also refer to as Python list of lists. And tabular data, guys, means data that is represented in a table format. So for example, a database table or of course a spreadsheet. Both of those are examples of tabular data. To briefly revisit the concept of the two-dimensional array, which of course you need to know about for your theory, and to give you an example of Python f-string formatting for you to use in your code and to study further if you wish. You may want to revise two-dimensional arrays, which you will find in video 19 in the Arrays, Records and Lists playlist, and video 36, which discusses Python list of lists in more detail as well. Just a reminder, as always, guys, the Python Monster resource folder on Schoology is there for you to supplement your learning from the classroom. You will find the videos, the Python Monster booklets, and also some other useful resources, including two PDFs which give you a catalogue view of all of the videos. Okay guys, so you will remember from the first video that I suggested we needed to go back and have a look at one-dimensional and two-dimensional arrays. If you have a look on the screen, you can see an extract from the OCR spec for your GCSE course, and on the right there I've put a little box around something which you need to be aware of for your theory, and it says the use of 2D arrays to emulate database tables of a collection of fields and records. So what this is actually saying is that when we store data in a database, like Microsoft Access for example, that data is presented to us in a table. A database table has its own set of terminology. We call the columns in the table the fields, and we call the rows the records. Now, as I'm sure you are aware, we can also represent data in a table format in Python using a two-dimensional array data structure. Now, Python programmers often refer to two-dimensional arrays as a list of lists because we don't have the array data structure in Python, but nevertheless we tend to end up with data that's very much like a table. How do we get from a database table to a two-dimensional array? Well, there are different ways to do this, but you've probably guessed that the focus here would be to save or export the data from a database table into a CSV file format as delimited data, and then to read the data into a two-dimensional array in Python so that we can preserve the table formatting and still be able to identify the individual fields or columns of the table and the individual rows or records of the table. And that's what this video is all about. It's about representing data in tabular form using a CSV file format and the two-dimensional array data structure, which we can simulate in Python. So where are we going with all of this? Well, we're going to be working with a CSV file of delimited data which has been exported and saved from Microsoft Access. Now, in the process of doing this, guys, I also created an Excel spreadsheet copy so that it's easier for you to open an example of the original data in its original table form. And that's because not all of you will have Microsoft Access on your computers at home. So we're going to be sticking with the database table terminology, but I have given you an example of what that table data might look like if it was represented in a spreadsheet. Now, in the original form, our table stores information about some games available on Steam, the name, the genre of the game, its date of release and the current price in dollars, and its priority on a wish list. So yes in that field means intends to purchase, and no means not purchasing this game for the time being. Now, once this table has been exported to a CSV file of delimited data, it looks like the format and the file at the bottom of the slide. Data whose values are separated using a comma, so we say that the comma is our delimiter in this particular example. Just to reiterate the typical terminology, guys, you can see on the slide here that we call each individual column of our table the field. Okay, so we have a field representing the name, a field representing the genre, a field representing the date, etc., etc. And we refer to the rows of data as being records. So we have a record which refers to Hacknet, a record which refers to Age of Wonders, a record that refers to Northgard, okay, and you get the gist. So in our code, what we want to be able to do is to read in each individual record from the CSV file, and then to be able to represent that in a two-dimensional array. When we print out the contents of our two-dimensional array, it will look like the format that you can see at the bottom of this slide. And you can see straight away, guys, that we have got a lot of similarity between the way that we have represented our data in a two-dimensional array compared to the way that data was represented in its original table format in Microsoft Access. Again, guys, you can quite easily pick out the individual fields which would be represented in the table, and the individual records which would be represented in the table as well, using a two-dimensional array, and then printing that out with the relevant formatting gives us exactly the same type of representation of tabular data. So when we finished writing our code, the output will be what you see on the screen. So this actually represents the evolution of turning the data that's in a two-dimensional array into a format on the screen. So we'll be using a special type of print formatting to represent the data as realistically as possible compared to the original database table format. So the first example of output that you can see on the slide, guys, is the raw two-dimensional data, okay, or two-dimensional array data, and you can see clearly on the slide there that essentially we have lists of individual string values which sit on top of each other, hence the term list of lists. But also, guys, you can pick out the fact there that we've got the makings of a table format, okay, the way that a two-dimensional array essentially represents data in a table format, you can actually begin to see in the first example of raw output that we have on the screen. The second example of output is where we have iterated through and printed out each of the values of data in the lists, so that we've sort of taken away the commas and we've taken away the brackets that represent the list data structure. And then finally, using f-string formatting, which you will see an example of in the code, we've positioned each of the items of data to be formatted into individual fields, so that you can begin to see how closely a two-dimensional data representation matches with the table that you would see data represented in a database. So guys, with that in mind, let's write the code that produces the output that you saw on that slide. Let's do the Python demo. So guys, on the screen you can see the Python code which I've written to generate the output which you're familiar with from a previous slide. We start off with the raw list data, okay, which essentially represents our basic two-dimensional array. In other words, it's a collection of lists which you can see on the screen, one on top of each other. Each one of those lists is representing an individual record contained within our CSV file. What we've then done is a little bit of jiggery-pokery to format by iterating through the lists and just plucking out the strings. So we've got rid of what looks like the original list structure with the brackets, and also, of course, the quotes and the individual commas that separate the values in the list. Okay, so we've sort of got rid of the list format and just represented strings. And then finally, we've used a special type of formatting called f-string formatting, where we can actually put all of these values into formatted columns, which of course we call fields, because we're talking about the relationship between our data and the original table that we had in our database. So guys, I'm just going to quickly put up a slide to explain what's happening here, because normally what you've seen so far, and particularly if you're not overly familiar with two-dimensional arrays, is in all of the examples we've used so far with lists, each of the items in our list has been an individual value or an individual data item, like a string, for example, or an integer or a float. But what we're actually doing here is we're taking a set of lists and we're putting those together into a parent list. So we have a list which comprises individual lists, okay, rather than individual items of data like strings or numbers. So just have a quick look at the slide, guys, just to make sure that you are comfortable with the way that we are creating a list of lists here. Okay, so let's go through each of our section of code and explain to you how this works. And let's start off with the comments that I put at the very top. It says an example of using a Python list of lists, which we could also refer to as a two-dimensional array, to store data in a table structure and then to format the data to represent it as individual fields and records. So in other words, as closely representative of our original database table as possible. So the first thing I've done is I've declared a Python list. Okay, I'm not working with initializing two-dimensional arrays. Okay, I'm not emulating the array data structure, guys, here. I'm just using Python lists. But I'll talk a little bit more about how we can talk about two-dimensional arrays when I've gone through the code example. So the first thing that we need to do, guys, our major bit of mechanics is to open and read the data, the delimited data from our CSV file. And you can see that in this block of code here, guys. Okay, so this is our file handling. So what I'm going to do in a second is I'm just going to zoom in. I'm going to go through each line in our file handling block of code. Okay, so let's get rid of that and let's just zoom in. There we go. So you'll be familiar with a lot of this already, guys. We've got the standard syntax that we use for file handling. We have opened a file called mygames.txt. That's our delimited CSV file, which is the output from exporting the Microsoft Access table of games information, okay, which you saw earlier. And our mode is R for read, because we're only reading the data in, we're not doing any writing here. So of course we have the condition for iteration while the row does not equal null. Okay, so that's the equivalent of while not end of file. And then the first thing that we need to do, guys, and you will remember this from previous videos in the playlist, we need to remove the escape characters, which will be in the string that tells Python to start a new line. Okay, so I have used the Python strip function to remove the escape characters \n, so they won't appear anymore in our lists. Okay, and you've seen that before in a previous video, guys, where we've been looking at basic file handling. The next thing I need to do, of course, is I need to take the individual string which has been read in from the delimited file, from the CSV file, and I need to convert that into a list of individual items. Okay, so this is the bit of code here where I said row becomes, okay, and then row.split, and I'm using the comma because that is our delimiter in the file. Okay, so now what I've got is I've converted a string from a simple string into a list of individual items, and of course the individual items will be the key, the name of the game, its genre, the date, and of course the price and our priority on the playlist. So here, guys, this is the bit where I'm creating my list of lists, because what I'm doing is I'm taking the list that I just created and I'm appending the list as an individual item in games lists. All right, so this is where I'm creating my parent list, which comprises of child lists, if you want, for want of better terminology. And then, guys, of course, what I do is I wrap up at the bottom of the iteration. I wrap up with reading in the next line from the file, okay, the next record from the file, in readiness for the next iteration. All right, and that essentially is the end of our file handling block of code here, guys. Okay, so let's just get rid of all of those boxes and let's move on to the next block of code, the next section of code in our solution. So our next block of code, okay, or our next little section of code is this part here, where I've said print the lists as records of string values using Python collections iteration. So quite simply, guys, I've taken the what has now been created as a two-dimensional array, and I'm iterating through that, and I am printing out each of the lists in my parent list collection. Okay, and this bit here is what generates the output that you can see on the screen here, guys. All right, so this is our raw data, if you like, our raw format as a two-dimensional array, essentially a list of lists. Okay, and what we've done is we've iterated through and we've printed out each individual item in our collection, and each individual item happens to be a list in its own right. Okay, so let's get rid of that. So that's our first example of output. Okay, so in order to get rid of the traditional list formatting, if you like, with the commas and the quotes and the brackets, of course what we need to do is we need to isolate the individual string items in our list. Okay, and that basically happens here, guys. So we've got a nested loop. All right, so let me just go through this with you and explain how this works. All right, so what we're saying is we start off, okay, by picking out each row, in other words, each list in our collection, all right, each row in games list, and then for each of the rows that we pluck out, okay, we cycle or iterate through each of the values in each of our rows. Okay, so what I've said is for rows in games list, all right, so that isolates a particular list in our collection, and then for each list that we're iterating through, we look at each item in the list. So of course that will be the key, the name, the genre, the date, the price in dollars, and our priority on the wish list. Okay, and then I process each of those simply by printing them out on the screen. Okay, so it's a nested loop which allows us to drill down and isolate each of the string values within each of our individual lists. Okay, so that's our basic formatting then, which results in this output here. Okay, and then because I've used a nested loop and because I've drilled down to the individual string values, of course, we no longer see the original list type formatting with the square brackets, the quotes, and the commas. Okay, and you've seen something similar in previous videos. Okay, guys, so let's go down to this special technique that we have that's available to us. All right, which is our ability to be able to take this type of data, okay, and then to actually format those into consistent columns. Okay, and of course, like I said earlier, we're actually talking about fields of a database table, so that's the terminology we should be using here. And what we end up with is this really nice looking output, which really does resemble what we saw from the table either in the spreadsheet or as would have been represented in the database, guys. Okay, where you can see that each of our individual types of data has been nicely formatted on the screen. So how do we get that? So let me explain f-string formatting to you. Right, before I do that, guys, just obviously to say that you don't need to know this from either a theory perspective or indeed from the perspective of your practical programming project. It's a nice to have. Okay, you are not going to be expected in a practical programming project to be using this type of formatting, but I know that a lot of you watching this video will very much like to be able to produce output which is really formatted well. So not showing you how to do this, and it's not challenging to be able to do this, guys. Feels like it's detrimental for you. So I'm just going to give you a simple example of f-string formatting at the bottom, tell you how it works, guys, and then of course you're at liberty to go and explore that in your own time and to incorporate that into your code as well in the future. So the first thing to say, guys, is that I noticed when I was doing the video that in the code that I wrote prior to the video, obviously, I'd forgotten to pop in a column to represent the genre, which is a bit naughty, really. It's an oversight on my part. Nothing else in terms of the learning, nothing has changed, really, but I've just added that in to make sure that we do actually include it in the final formatting, guys, which now looks like this. Okay, so you can see that there's an extra field that now appears, okay, to cater for the genre of the game, which of course was in the original table in Microsoft Access. So I've popped that in, guys. Okay, so the first thing to mention about f-string formatting. Okay, so f-string formatting is a particular type of formatting which is available from Python 3.6 onwards. So if for some reason this doesn't work on your computer at home, or possibly even on a machine in school, it's because it doesn't have one of the latest versions of Python installed. Okay, so Python 3.6 onwards enables you to use this specific type of formatting, okay, the f-string formatting, with this specific type of syntax here, which I will go through in a second. So let's go through this entire block of code step by step, and I will explain to you how this works. Okay, so we're here, essentially. So let me just get rid of that and zoom in a little bit so you can see this more closely. The first thing that we're doing, guys, as you can tell straight away, is that we're iterating. So what we're doing here is we are isolating each individual list, which of course represents each individual record from our original table in the database, and then we're looking to format across the screen each of those individual records. Okay, so that's why we're iterating. The first thing that we always do with this type of formatting, f-string formatting, is we need to unpack our list so that we have variables which represent each of the individual items of data in our list. And you can see that done here, where I've given my variables sensible names, guys. Okay, I have a variable for each of the individual items, okay, in the data. So I've got keys, name, genre, date, price, and sale. Okay, has been assigned the individual values of the list called rows. Right, once I've done that, I need to give the string which represents the special formatting a variable name, which I've done here. Okay, so the f-string formatting for each of those records in the table has been given a name of formatted rows. Okay, so once we've created our special formatted string, we can then of course print that out within our iteration, guys, and then it will eventually appear, okay, as you've seen on the output, which we will go back to in a second. So how does this syntax actually work? Well, the first thing to note, guys, if I just scroll across a little bit here, I think maybe we can squeeze all of this in. Yes, we can. So at either end of our string, okay, we have quotes, which you're familiar with, guys. Okay, so these are quotes which represent the data type of string. We use double quotes with f-string formatting, and to tell Python specifically that we're looking to use f-string formatting, we always have the little f character right at the beginning. Okay, this is what tells Python that we are going to be using our special syntax to create special f-string formatting. So let's have a look at these individual items of syntax then. You can see here that what I've done is I've taken each of the values, each of the variables I should say, and each of those variables appears in its own set of slinky brackets. Okay, the slinky brackets actually determine the formatting for the field or column of data that will appear on the screen. So that's fairly straightforward, but what on earth does this mathematical looking stuff here represent? It looks like maths operators, doesn't it? It looks like we're saying less than the integer 2. But in actual fact, guys, this is nothing to do with maths. Well, I suppose it sort of is, because we're using numbers to specify the width of columns, okay? But we're not doing mathematical conditions here, like is x less than 2, okay? What the actual less than means is to specify the width of a column. Okay, so when I've said here with keys, okay, less than 2, that means I'm asking Python to create a column which is the equivalent of 2 characters wide. Okay, now if it so happens that the data in that column doesn't occupy 2 characters, then Python pads out the rest of the column with blank spaces. Okay, and that's what creates the nice neat formatting for every single record that we have from our original table. Okay, now name is quite a good one to look at. Okay, so if I just scroll across so that you can see name, okay, let's just move this over a little bit if I can, so you can see both the code and the output, guys. Okay, so there's name. All right, we've got name here. Okay, and you can see here that name column, or the column that we're using to store the name, is a particular width. All right, and that caters for the longest item that I've got there, which is a plague tale. Okay, so that caters for the longest width of the individual item that I've got in that column. So in order to cater for that, I've specified a width for that particular column of 25. Now what that means is that Python will create a column which is 25 characters long, and the columns on either side of that will not impinge on that space. If, for example, if you look at Hacknet, for example, clearly Hacknet is not 25 characters long, but what Python does is it pads out the rest of the required space to fill out the column with blanks. Okay, so this is how it's working, and the same thing applies with all of the other columns as well. So genre, I've also specified a width of 25 characters. So if I move that across, you can see that there is our column, okay, that we're using to occupy with the data for the genre. Okay, and 25, a width of 25 is enough to cater for the longest string, okay, which is this one here. Okay, likewise, guys, when we come to dates, I clearly don't need 25 spaces, okay, to cater for a date. All right, so if I move this across to date, okay, let's just get rid of that box and redraw it so you can see it a bit more clearly. So here's date, guys. So really, the maximum width that I need for my column for dates is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I specified 12 just so I have a gap between each of the columns. Okay, Likewise with price, guys, I've specified a width of 12. I could probably have made that a little bit smaller if I'd wanted to, because if I scroll over, guys, you can see that actually there's quite a lot of space between the price column, okay, and the next column along, which of course is our wish list priority. All right, so I could probably have afforded to have made that a little bit smaller, okay, and then just crunch that up a little bit, but in actual fact that'll do fine. Now for sale, which is the last column that appears in our formatted output, let's just get rid of all those boxes. Sale I don't need to specify a column with, because essentially what Python's doing is it's bolting the last column on the end. All right, so because I don't have any columns after that, I don't need to worry about padding it out with spaces in order to make sure that the next column doesn't impinge on that space, because I don't have a next column. So I don't really need to specify a width for that particular column. Okay, so it looks a little bit, f-string formatting looks a bit alien and weird to start with, but once you get the hang of it, okay, and of course you've got Python 3.6 or greater installed on your computer, guys, it's really fun to be able to tinker around and format your data in a table format, guys. Okay, it looks really cool once you've got the hang of it. Okay, so that's the f-string formatting explained. Let me just zoom out a little bit. All right, now I wanted to explain to you what it is that we're doing here in terms of using Python, okay, but also using the terminology of arrays. Now you'll know, guys, if you've been through the videos on arrays, you will know that there is a special type of syntax that we use for initializing arrays, which is not the same as Python lists. I haven't done that in this example, okay, because in my coding example I am using Python lists and lists of lists, okay, in order to essentially simulate a two-dimensional array. Okay, now I'm quite happy to do that, because if, for example, in your practical programming project you were doing something similar, it is perfectly acceptable, guys, to say that you have simply stored your data from a delimited or CSV file in a two-dimensional array structure. Okay, it's perfectly acceptable to say that, even though you have used Python lists, okay, and you have declared your Python list here, okay, not strictly as an array, but as a Python list declaration. Okay, it's perfectly acceptable to say that you have used the equivalent of a two-dimensional array structure to store your table style data, which was exported from Microsoft Access, guys. Okay, I just wanted to clarify that you're able to use the terminology interchangeably, guys. There's not a problem with doing that. Okay, so that brings me to the end of this demo. There's a couple of things I wanted to cover off before we finish this video, guys. So I'm going to go back to a couple of slides and just talk about arrays, the traditional array data structure, and data types. Okay, so let's pop back to those slides now. So guys, here we are back with the slide where I took a screenshot of the GCSE OCR spec for your computer science, and the whole of this video has been about addressing the sentence in that box, which is knowing how to make use of two-dimensional arrays to emulate, in other words simulate, database tables of a collection of fields and records. And that's exactly what we've done, guys. I've given you an example of how we could potentially export a table from Microsoft Access as a CSV text file format with delimited data, and then use the equivalent of a two-dimensional array using Python lists to work with that data in a table format. Okay, having said that, I just wanted to go back around the loop with you on some of the rules that we have when we are specifically talking about arrays, because it says here two-dimensional arrays, guys. It doesn't say Python lists. So one of the things you may remember from previous theory, guys, and covering this in class and in other videos, is that both one-dimensional and two-dimensional arrays can only store data of the same data type. Okay, now this means that while we can still have lots of different data types represented in a database table, when we export the table to a CSV file format, we lose the original data type, and all of the data stored is as text. Okay, which is of course another way of saying the string data type. So to go back to the example that we used here in this video, when I originally created the database table that stores all of this information about games that are available on Steam, the database data type for date was actually the date data type. Okay, so all of the individual fields had a slightly different data type. Now, once that's been exported into CSV file format, guys, all of the data is essentially represented as a string data type. So that works really, really well with this idea that a two-dimensional array, or a one-dimensional array for that matter, can only work with one particular data type. But it does mean, guys, that in more complicated requirements and more complicated code, if you did want to work specifically with a particular data types, you then have got, of course, when you are iterating through and working with your data, you've then got to cast strings back to the original data type that you would have wanted them represented in your table. An example of that is the key. So again, in the original table in the database, the key was a number data type. In the CSV file, it's been converted to a string data type. So if I wanted to work with that data as numbers, of course, I would then have to cast it back from the string back to an integer, or possibly even a float if it was a slightly different example. So just wanted to cover that off, guys, at the end to make sure that you haven't forgotten that arrays in your programming can only store one particular data type. Okay, guys, that brings me to the end of this video. I hope you found it useful. As I've mentioned before, the code and files, text files that I've been using in the playlist are available to you on the Schoology folder, where the code examples are provided for you relative to each of the videos where they've been used. Okay, so I will see you in the next video.